Okay, tree diagrams. This is independent. So this says a bag contains 5 red balls and 3 green balls. A ball is drawn at random and then replaced. Now this is the important bit. If it's replaced, the probability doesn't change. And it says independent because it means that it doesn't matter what the first thing that happens. It doesn't change probability for the second one. It says another ball is drawn. What is the probability both balls are green? So we'll put first pick. You can have red or you can have blue. And there's 5 red balls. And that's out of a possible 8 balls because there's 3 green balls. So it's red and green, isn't it? Therefore, this bit here would be 3 green balls out of a possible 8. So that's the first probability. And then what happens is we have a second pick. So red, we're going to be 5 over 8 still. So you could pick a red and then a red, or we could pick a red and then a green, which is 3 over 8. Or we could pick a green and then a red, which is 5 out of 8. Or a green and then a green, which is 3 over 8. Now the question that asks us, what is the probability both balls are green? So we'd go green and green, so it'd be 3/8 times 3/8, because we've got green and green, which would be 9 out of 64. Now we could do this for a few different ones. So if we go in this way, it's a times. Sorry, it's a bit scruffy. If we have got more than one option, so if we wanted a red or green and red, we've got red and then green, so 5/8 times 3/8, which is 15 over 64. Or we could have 3/8 times 5/8, which is another 15 over 64. Now, because there's 2 options, we could either have green-red, this one, or red-green. Then it's what we call an OR question, because we've got OR here. And what we have to do is we have to add that one and that one, which will give us 30 out of 64. So if you're going this way across the tree, you times. If you're picking more than one of these options, then you have to add.